Okay, so here we are. This top problem here is problem number 13. This one down here is 14. I will not do either of these for you, nor will I write the equations, because that's the whole point of these problems, is to be able to read them and kind of figure out what's going on. There we go. But what I do want to kind of walk you through is maybe why you're struggling. There we go. So first things first. This problem, you have to read it, okay? And you have to say, all right, what is this equation talking about? It's the cost of controlling emissions at a firm, and the cost goes up rapidly, the amount of emissions go up. So here's a possible model. This is cost, where it is $6,000, I'm guessing, where you have plus 100 x squared plus 50 y squared, where x is the reduction in sulfur emissions and y is the reduction in lead emissions in pounds of pollutant per day. Okay, so the more you try to pull out, the higher your costs are going to go. And C is the daily cost of the firm in dollars. Okay. The government clean air subsidies amount to $500 per pound of sulfur and $100 per pound of lead. That's not in here anywhere. So if you're trying to find out how much it actually costs you, you've got to work in the $500 per pound of sulfur and $100 per pound of lead removed. And if you are unaware of what the word subsidy means, it means that the government gives you that money to help offset your costs, to help make it cheaper. So for example, if you buy a brand new energy efficient pool pump, the government will give you a quote-unquote subsidy of $100 to make it so you get $100 back from the government, so to kind of encourage you to buy a new energy efficient pool pump. So businesses have the same thing, where the government will give them subsidies to help encourage them to be a cleaner company. So you, into this equation, need to work in the $500 per pound of sulfur, $100 per pound of lead, work that into here. I'll give you a hint, it's not hard, it's just adding or subtracting. And it's per pound, so you don't have to mess with this. You're just going to add on to it or subtract from it or do something like that. And then you're going to do your partial derivatives with respect to x, with respect to y, to find the max, find the saddles. Okay? Min, maxes, and saddles. Now, problem number 14. This problem, again, you have to read and see what are these equations talking about. This first equation, P. All right. Well, first of all, we're talking about two different kinds of speakers, and logic says if you have two models, kind of like a high-end model and a low-end model, and the prices are too close, people are just going to buy the high-end model. So as the price of the cheap model gets closer to the expensive model, that affects the quantity at which people will purchase of the other models. That's what's going on here, of the other model. That's what's going on here. So what they're telling you here, P1 is the price of the Ultra Mini. So there's P1. P2 is the price of the big stack, P2. And demand for the Ultra Mini is defined by Q1. So therefore, the demand is dependent on the price of the Mini and the big. And then similarly, the demand for the big stack, Q2, is dependent on the price of the Mini and the price of the big. So as a company, you don't want to set your prices too close, because then no one will buy your low-end stuff. So the question here, what they want to know is, what will maximize our total revenue? So you got to think about what is revenue? What's the equation for revenue? And I will give you this. Even though you probably already know it. Revenue, by definition, is just how much money comes in, and that would be calculated by the price at which you sell the item multiplied by the quantity you sell, by the number of them that you sell. So if I sold candy bars at $1 and I sold 100 of them, that means my revenue is $100, right? Notice that doesn't mean profit, because we don't have cost anywhere worked into here. All we're trying to do is maximize the amount of money coming in. So the question is what price should you set each of these things at to maximize revenue? So you're going to need to use this first equation, this second equation, to come up with a revenue equation. And again, it comes back to that very simple equation of quantity times price. Okay, and you've got two items, and then you're going to need to make them into one equation. Use this and this. These are both quantities that you're going to sell. You need to somehow relate them into revenue. You're going to have one equation, then you're going to take partial derivatives of that with respect to P1, with respect to P2, solve, find the mins, max, and saddles using the d-test. Okay, I hope that was a good enough hint to get you going. And there we go.